In this tutorial, we're going to take a look at some examples involving inequalities. This tutorial relates back to the lesson on solving multi-step inequalities, so we're going to just go through a couple of examples just to make sure we understand the steps involved and the justification for those steps. And so the instructions say to solve each inequality, check your solutions. So take a look at the first inequality. We have m added to 7 is less than or equal to a -3. So the steps are going to look familiar because we're going to be using properties of inequalities just like we use properties of equalities to solve equations. The first thing we need to do to isolate the variable is undo this add 7. We can undo add 7 by subtracting 7. The subtract property of inequality says that as long as we subtract the same amount from both sides, the inequality remains true. And so we're going to subtract 7 from both sides of the inequality. When we do that, we get the 7 and the subtract 7 is 0, so we have m is less than or equal to a -3 subtract 7 is -10. Okay, now that looks like the right answer, but we're going to check. So let's do a quick check just to verify. Now to check an inequality, you want to pick a value that falls within that range and then a value that does not fall within that just to verify. So let's start with m. Since we're saying that m is less than or equal to -10, let's start with m is equal to -11. And let's plug that into the inequality. So we have -11 add 7 is less than or equal to -3. Well, we know that -11 add 7 makes -4, and we're comparing that to a -3, and sure enough, -4 is less than or equal to -3. That's true, so -11 is one of the possible values. Now let's check when the value does not fall within that interval. So for instance, let's do m is equal to 0 because we know that 0 is not less than or equal to -10. When we plug 0 into the inequality, we get 0 added to 7 is less than or equal to -3. We know that 0 added to 7 is 7, but take a look at this statement. It says 7 is less than or equal to -3. That's a false statement. So because it's false, we know that 0 is not a possible solution. So we were right, and we verified that m is going to be less than or equal to a -10. The next inequality says 5 is greater than or equal to 2 multiplied by the group n subtract 3 add 7. So it's the same idea. We're going to isolate the variable. So one thing we need to do is to take a look at these two groups. We have 5 is greater than or equal to 2 groups of n subtract 3 tells us we have 2 multiplied by n and 2 multiplied by 3, so we have 2n subtract 6 add 7. When we combine the like terms, a subtract 6 or a -6 add 7 makes a +1, so we can rewrite the inequality as 5 is greater than or equal to 2n add 1. Okay, now let's isolate the variable. To do that, first let's tackle this add 1. The opposite of add 1 is subtract 1. So let's use the subtract property of inequality and take away the same amount from both sides. When we do that, the inequality is now 4 is greater than or equal to 2n. To find what to solve for n, we will undo the multiply with division. When we do that, we get that 4 divided by 2 is 2, and 2 is greater than or equal to 2 divided by 2 is 1, so now we have 1n instead of 2 n's. Now, using symmetry, we can also state that that is the same statement, or saying the same thing, as n is less than or equal to 2. Notice the greater value is 2 in both statements, or the value that is greater than 2 is written 2 is greater than or equal to n, or n is less than or equal to 2. Equivalent statements. Let's do a quick check. So the first thing we're going to do is check a number in that interval. So since n can be less than or equal to 2, let's start with n is equal to 2. So we have 5 is greater than or equal to 2, and then we have in the parentheses 2 subtract 3, and then we have add 7. Alright, well now let's rewrite that inequality as 5 is greater than or equal to 2 take away 3 is negative 1, and 2 times a negative 1 is a negative 2. Then we add 7. When we compare both sides, we see that we have this 5 is greater than or equal to a 5, and since 5 is greater than or equal to 5, and 5 is equal to 5, we have a true statement. Okay, let's check a number that does not fall within that interval. So let's try n equals 3. So we write the inequality as 5 is less than or equal to 2 multiplied by 3, take away 3, add 7. Well, that gives us 5 is greater than or equal to 3 take away 3 is 0, 2 times 0 is 0, and 0 added to 7 is 7. When we look at the statement 5 is greater than or equal to 7, we know that's not a true statement, that's false. And so that means that 3 is not a possibility or not a possible solution. So we verified that n must be less than or equal to 2. This next example says solve the inequality, graph the solution set on a number line. So again, we're just going to use the properties of inequality. As long as we subtract the same amount or add the same amount to both sides, the inequality, the statement does not change. So as we look at this inequality, we notice we have x's on both sides, so we can take a maximum of 6 x's away from both sides. When we do that, we're left with x subtract 5 is greater than 4. In order to isolate the x variable, we need to make this subtract 5 into 0. We do that by adding 5. The addition property of inequality says that we need to add 5 to both sides to maintain the truthfulness of the statement. When we do that, we get x is greater than 9. So that's our solution. Now, that solution can be represented in one of two ways, in interval notation or in set builder notation or set notation. In interval notation, all we're doing is basically just saying where are the possible number values. Well, we can go, since the inequality says that we have x is greater than 9, that means that x can be any value above 9. So we could say that the interval is from 9 all the way up to infinity. Now we're going to put parentheses around the 9 because 9 is not included, and we're going to put parentheses around infinity because it's not a specific value. So this is what we call interval notation. Set builder notation is just a way of saying that our solution is any real number that meets the conditions of x being greater than 9. So we're going to use the brackets for set notation, and we're going to say that x is an element of the real numbers such that x is greater than 9. This is what we call set builder notation. Now, in order to graph the inequality, again, we're saying that the value for x can be anything above 9. So we're going to use 9 as our reference point. So we're going to graph right there at the 9. And then we're going to identify all the possible values by drawing an arrow in the direction of all the values, all the way pointing to infinity. And there you have the graph of the solution set on the number line. Let's take a look at this word problem. It says Carlos needs 280 points out of 350 to earn a B grade. He has earned 180 test points and 40 homework points. How many points must he earn on his final test to earn at least a B for the quarter? Okay, so remember, at least means we can be above the point total or at the point total, but we can't go below the point total. So that's at least. Whenever you see the words at least, think greater than or equal to. Okay, so let's see what we've got here. Carlos has earned 180 test points, and he's earned 40 homework points. And he has a final test coming up. He hasn't taken the test yet, so we don't know what the total number of points is that he's earned. But combined, those points need to be at least 280 in order to earn the B. We can be above the 280, we can be exactly at 280, but we cannot go below 280. So we're going to use the greater than or equal to inequality for this. Okay, so now let's go ahead and solve this inequality for x. First, we know that 180 added to 4 is 220. So we have 220 added to x is greater than or equal to 280. To isolate the x, we need to make the 220 into 0. We can do that by subtracting 220. We'll use the subtract property of inequality to subtract 220 on both sides. So 220 subtract 220 is 0, and so we're left with x is greater than or equal to 280 subtract 220 is 60. So according to this inequality, Carlos needs to earn at least 60 points in order to earn a B grade.